So, good morning, students. Today we will deal with another interesting topic, which is limiting reagent, and many questions are framed from this topic. This topic is in chapter 1, some basic concepts of chemistry. So, let me find a marker for myself. Where's the marker? Yes. So, today is 22nd January when I'm shooting this video, and it's the Udhyapan, what we call in Hindi of Ayodhya Ram Mandir temple. So, to all of you, great wishes of that, and we'll start with Jai Shri Ram by saying Jai Shri Ram. We are starting the video today. Okay, what is the topic? Limiting, limiting reagent, reagent. Limiting reagent. By the term, we can understand limiting reagent means that limits the chemical reaction, that limits or that controls the chemical reaction. So, let me get some theoretical. The reactant that gets consumed during the reaction and which limits the amount of the product means limiting reagent is the reagent which gets consumed first and limits the amount of reaction or amount of product. Okay. So what is the reagent left out? That is called the excess reagent. The reagent present in excess is called excess reagent. Means the reagent which is present in extra quantity is called excess reagent, while the reagent which gets consumed first and that limits the amount of product is called the limiting reagent. Simple. Now, this was the introduction. Now, how to find the limiting reagent? That I will tell you. How to find the limiting reagent. I'm rubbing this out. So, step 1. So, what is the step 1? Divide the given moles of reactant. Divide the given moles of reactant by the respective stoichiometry coefficient of that reactant, by the respective stoichiometric coefficient of that reactant. So divide the given moles of reactant by the respective stoichiometry coefficient of that reactant. Means if this is a general equation, small a capital A plus small b capital B gives small c capital C plus small d capital D. So the small a is the stoichiometric coefficient, and suppose initial moles of A are 2 and of B it's 4. So we will divide 2 by A and 4 by B. This is the first step they are talking about. This is the first step. I've mentioned with the help of an example. This is the first step. Now note down the first step. I will revise the first step again. Divide the given moles of reactant by respective stoichiometric coefficient of the same reactant. Means suppose moles given of A are 2, then 2 by small a, that is stoichiometric coefficient, we will divide. This is the first step. Okay. Now we will talk about step 2. Step 2. See that for which reactant the divisions come out to be minimum. The division comes minimum. The reactant having minimum value is the limiting reagent. So what is the step 2? See that for which reactant the division is coming minimum, and that reactant which is giving the minimum value is the limiting reagent. Suppose we took an example, preparation Haber's process I am taking. N2 plus 3H2 gives 2NH3. This everybody is aware of Haber's process, which we all have studied in class 10th. Yes, Haber's process. So if moles of this, I am giving the moles of N2 are 2 and moles of hydrogen are 3. So I will divide this by stoichiometry coefficient as by first step. So first step I will write step 1. So 2 divided by 1 and 3 divided by 3. This will give 1 and this will give 2. So you can see that this is minimum. The division in hydrogen is coming minimum. Means hydrogen here is the limiting reagent. We got our limiting reagent. This is the step 2. Please write down the step 2. Meanwhile, I am reversing it. See that for which reactant the division comes minimum. The reactant having minimum value is the limiting reagent. Haber's process we all know. I have given the moles of nitrogen 2 and of hydrogen 3. 2 by 1, 3 by 3. So this value is coming 2 and this is 1. So 2 is greater than 1. So which is less 1. So this is the limiting reagent, and also we can say that N2 is excess reagent. That is N2 is present in excess. That we can also say. Now let's go on to step 3, which is simple calculating step. Main aim was finding the limiting reagent, and rest all is simple. Step 3. What it says, now we found the limiting reagent, then our focus should be limiting reagent to find the amount of product. Using limiting reagent, find the amount amount of product. Find the amount of product. So let's consider the same example of Haber cycle I am giving. Example, N2 plus 3H2 gives 2NH3. So I will give the moles, initial moles. I will give N2K 2 moles, H2 3 moles. Okay. Let's take it 5 to make 5 moles. 5 moles. So let's find the limiting reagent. Step 1 we will do. Step 1 I am doing. Step 1 I am writing here. 2 divided by stoichiometric coefficient. 5 divided by stoichiometric coefficient. Okay. What is the value coming here? It is 2, and what is here? 5 divided by 3. What it comes? 1s are 26. 1.67. You can see that this value is less, so I will write H2 is limiting. Is everybody getting? First step may divide the given moles by stoichiometric coefficient, the value of which is minimum. The value of which is minimum will be the limiting reagent. For H2 it's coming 1.67, for N2 it's 2, so 1.67 is lesser, so H2 is limiting. Simple. Now how to calculate the product? Just simple. We are asked the moles of the product. What we will do? Simple. Do with me. Simple unitary method I am doing. 3 gives 2. 3 gives 2. 5 were the initial moles. 5 will give x. Calculate it. X is equals to 10 by 3. 10 by 3, x is equals to 3.33. X is equals to 3.33. So the moles of NH3 formed are 3.33. I will give you another short trick for this. Directly 1.67 I got into directly the stoichiometric coefficient of NH3. 1.67 into 2. Directly you will get this answer. But for those who are using unitary method, they are also correct. But for exam shortcut I am giving you, ये तुम्हारी वैल्यू आ रही है डिवीजन के बाद 1.67, उसको सीधा इसके स्टोइचियोमेट्री से इनटू करने वाले अपन, उससे अपने को सेम आंसर मिलने वाला है. सिंपल. ओके, नाउ वी हैव done in 3 steps. First step cleared. Second step we find the limiting reagent. In third step we are using the limiting reagent to find the amount of product. Now as you are familiar with all the limiting reagent concept, we will solve 4 questions in this class, and you have to pause the video each time and comment the answer. Those who are getting the right answer will get a heart from me. Okay. Just start with the easy question. Okay. Six moles of N2CO3. Okay. 6 moles of N2CO3, that is sodium carbonate. 4 moles of HCl are made to react. 4 moles of HCl are made to react. Find the volume of carbon dioxide at STPT. This is the given thing in the question, and what we have to find is that volume of carbon dioxide at STPT. This term is very important. At STP, standard temperature pressure. Okay, let's now pause this video, and comment your answer. And if you are not sure with the answer, you can watch the solution. Continue with me. Okay, I am doing it. First, our basic step is to write the chemical reaction because they are reacting. N2CO3 plus HCl gives NaCl plus CO2 plus H2O. Simple. Let's balance it. Here it is coming to, here I have to add 2, here I have to add 2 H2, yes, 2 C1 CO3 O3 H2 H2 Cl2 Cl2. Balanced. Perfect. Moles given. I will write moles. This is 6 and this is giving 4. Now step 1. 6 by stoichiometric coefficient 1, 4 by stoichiometric coefficient 2. What is the value coming here? 6 and here 2. So this is the limiting reagent. So I will write HCl is limiting reagent. Now we have to find the volume of carbon dioxide at STP. So I will use the formula moles of carbon dioxide is equals to volume given by molar volume. Molar volume here will be, yes, 22.4 liters. Okay. Now how to find the moles of carbon dioxide? Simple unitary method we will do. 2 HCl gives 1, then 4 will give how much? So it will 4 ones are 4. 4 divided by 2, 2. So X is coming 2 moles. 2 moles. Or I gave you a short trick. 2 into stoichiometric coefficient 1. 2 into 1, 2. Okay. The formula I will use 2 into volume given by molar volume. What is the molar volume at STP? 22.4. So answer volume is equals to 44.8 liters. 44.8 liters. Who got this answer? Who? The students who are getting this answer, they are going with the right concept, and students who are missing some steps, they have to practice, or they can rewind and watch the steps, the 3 steps. By basic 3 steps we are solving this question. Okay, now I am rubbing it out. So what is the question 2? I will see question 2 here. Okay. If marker is a little bit tight, take the next marker. If 0.5 moles, 0.5 moles of BaCl2 is mixed with 0.2 is mixed with 0.2 moles of Na3PO4, that is sodium phosphate, the maximum amount of Ba3PO4 twice produced, means we have to find amount of Ba3PO4 twice. same concept we are using. Pause the video and solve this question and comment the answer. Comment, yes, comment. Everyone should comment. Let's first step to write the balanced chemical equation. BaCl2 plus Na3 del PO4 gives simple substitution reaction will give NaCl plus Ba3PO4 the whole twice. Okay, I will make this 6 NaS. This I will add 2 3. Now everything is balanced here. You can see balanced equation I wrote. Now moles given. Here 0.5 moles and here 0.2 moles. Divide step 1. Divide the given moles by the stoichiometric coefficient 0.5 by 3 and 0.2 by 2. So 0.5 by 3, what it will come? It will come 0.167 and this will come 0.1. So this is less. So I can write Na3PO4 is limiting reagent. Everyone got the limiting reagent? Those who are solving with me? Okay. Na3PO4 is limiting reagent. Now what we have to find? Amount means I will use here simple formula. Number of moles of Ba3PO4 twice is equals to amount given by molar mass. Okay. So unitary method, those who are comfortable with 2 से 1 मिल रहा है, तो 0.2 से कितना मिलेगा? So 2.2 into 1, 0.2 divided by 2, 0.1. So X is equals to 0.1 moles. Okay. So 0.1 into weight by molar weight. Calculate the molar weight. What is the molar weight here? Ba3 का barium. What? Check the molar weight of barium. Atomic mass of barium. Yes, it's 137. So once at 37 threes are 137 into 3, or 21, 2 carry 11, 1, 411 plus 31 2s are 62 plus 62 plus 8 16 8s are what it comes? Yes, 128. Now this will be 10 1 carry 6 190 411 plus 190, what it comes? 90 किया तो 411 plus 190 110 601 is this. So 1 by 10 into W by 601. So weight is 60.1 or 60 grams I will write. So amount of Ba3PO4 formed is approximately 60 grams, or you can say 0.1 moles of Ba3PO4 is formed. Second question is done. Clear the concept. Okay. Let's move on to the next question. The third question we will see. Now I am giving my own question to you. What is that? Simply by I will give you a simple reaction. What is that? Okay. Yes, the Haber's process only I will give. N2 plus 3H2 gives 2NH3. So moles given 2 phi. So you have to find weight of NH3 and the excess reagent left. Excess reagent left means if the reaction is carried out, what is left in excess, and that amount of excess we have to find. Okay, this is slightly a tricky question because people find it difficult to find the remaining excess reagent. So let's go to our first step. Step 1, simple. 2 by 1, 5 by 3. 5 by 3 is 1.67. This is less, so H2 is limiting reagent you found. Now simply, weight we have to find. So moles I have to find first. So 3 gives 2, 1.67 gives X. What it's coming? 3 is giving 2, 1.67 gives. Okay, I will calculate. 1.67 into 5 gives here. 5 gives 7. So it is coming X is equals to 3.33 moles. 3.33 moles. Now simple formula, moles is equals to given mass by molar mass. Given mass we have to find. What is that then? 3.3 is equals to X by 17. So 17 into 3 I will do. What approximately I am calculating the answer. 7 3s are 21 to carry 51 grams of NH3 is formed. That is the first part of the question I have completed. Now excess. Let's solve for excess. So this is used. So this will be consumed. So you have to simply use that 2 minus 1.67. Why? Because only 1.67 hydrogen is used, so left out from N2 is 2 minus 1.67. So what it will come? 2 minus 1.67. Okay. 3 I will add, so 10, 70, 33, 0.33. 0.33 it is coming. So 0.33 moles is left. 0.33 moles are left, but we have to find the excess reagent का कितना weight बचा है. So moles is equals to mass by molar mass. What is molar mass of N2? It's 28. So simply you can calculate. I will write this by 3 by 10. 3 by 10 I can write. So 28 into 3 by 10. 28 3s are 24 to carry 84 by 10. 8.4 grams of N2 is left. 8.4 grams of N2 is left. That is, N2 is the excess reagent, and that underreacted mass is 8.4. That way also they can frame. What is the underreacted mass of the excess reagent? That we have calculated. 2 points are done. Okay. So, sufficient practice or sufficient type of questions I have given you. Now your job is to practice the NCERT questions and let me know if you are finding any difficulty in this topic. We have completed the theory of limiting reagent with all concepts plus some questions we have discussed. So thank you for watching.